Welcome to ClickMyProject.com. Now we are going to discuss about the project ICA with CWT and K-means for eye blink artifact removal from fever channel EEG. Now we are going to discuss about the abstract of the process. In this process, we propose a versatile signal processing and analysis framework for EEG signals. Within this framework, the signals were decomposed into one frequency subbands such as then alpha, beta, gamma, theta and gamma, delta using the decomposition methods, and then a set of statistical features was extracted from the subbands to represent the distribution of wavelets coefficients. After extracting the features, we have using the independent component analysis and continuous wavelet transform, that is the ICA and CWT is used to extract the features from the decomposed signals. So the decomposed signal is already denoted as alpha, beta, gamma, theta and delta. So after extracting the features, to reduce the dimension of the features, we are using the ICA and CWT. Then these features were used as an input to the support vector machine, that is the classifier. So why we are using the classifier means, in the classifier we are going to classify the input signal is normal or abnormal. Finally, the performance of the process is evaluated by means of the accuracy, sensitivity and specificity. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The module consists of this project is input signal, pre-processing, feature extraction, feature matching, that is the classification, then finally performance estimation. At first, the input signal is taken from the dataset. The dataset is nothing but the collection of data in which the signals is collected in this dataset, which having the both of normal as well as the abnormal signals. After getting any one signal from the dataset, we just move to the pre-processing. So in this pre-processing, we have an pre-processing like the signal limitation and signal decomposition methods. So in this signal limitation, if the input signal length is too high, means it will be reduced into 1000, or else it will be remains the same. So after that, we will go for the decomposition in the pre-processing stage itself. So in this decomposition, we have converted the signal into an alpha, beta, gamma, theta and delta. After getting this 5 outputs, we just move to the feature extraction step. In this feature extraction step, we have two kinds of algorithm named as ICA and CWT. By using the ICA and CWT, we are going to extract the features from alpha signal, beta signal, gamma, theta and delta signals. So ICA is applied for these 5 signals, then CWT is applied for these 5 signals. After applying these 5 signals, we are extracting the features, then we go for the feature matching process. In this feature matching process, we have 3 kinds of input for the feature matching, that is nothing but the classifier. So the 3 input is, first of all, the test feature obtained from the ICA and the CWT, then the train feature, then finally labels. Label consists of the 2 categories, one is the normal as well as the another one is the abnormal. After getting these 3 as an input for the classifier, we just applying the multi-SVM classifier to classify whether the input signal is normal or abnormal. After classifying this one, we just move to the final stage of the project, that is the performance estimation. This performance estimation, we have 3 kinds of performance parameters like accuracy, sensitivity and specificity. By using these 3 parameters, we can justify our processes efficient or not. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015B and then change the current directory. If you want to execute the process, just right click in the main_GUI.m and select option run. Once you selected the option run, the new GUI was open. In that GUI, you can see the several push buttons in the right side for the controlling actions. Then several axes and table in the left side for the display purpose. First of all, click the button input signal. After clicking the button input signal, you have to open the dataset folder, then select any one signal from the dataset. After the selection of the signal from the dataset, the corresponding signal will be represented in the axis 1 with the title of input signal. Actually, this is the input EEG we have taken from the dataset. After after that we just move to the pre-processing. So in this pre-processing, filtering is applied as well as the signal limitation is applied. So if the length of the signal is more, means it will be applied to the signal limitation. Now this figure 2 represents the filtered signal. Then feature extraction starts here. Now click the button feature extraction. After that the feature extracted will be done one by one. Now this is the first stage. Here the data is split into one alpha, beta, gamma, theta and delta. So these are the 5 signals. This is the decomposed signal. After the signal decomposition, we just move to the plotting stage of the alpha signal values, beta signal, gamma, theta and delta signal values here. So this table represents the values of alpha, beta, gamma and theta, delta signals. Then after that CWT is applied. So CWT is applied for alpha signal. So this is the signal values for the CWT. This is the signals of the CWT of beta. Then this is the signal of the CWT gamma. Then this is the signal of CWT theta as well as CWT delta. So after extracting this 5 values, now the ICA value is also extracted here. Now the ICA value is shown in this table. Then this table represents the feature vector. Feature vector consists of the ICA along with the CWT. So these two are combined together to generate the test feature. So after generating the test feature, we are going to apply the classification stage. In this classification, it will be classified as whether the input signal is normal or abnormal. If it is a normal or abnormal, it will be displayed the results like this. After that, we just move to the final stage of the project, that is the performance estimation. We already discussed about the performance estimations like accuracy, sensitivity and specificity. So the values of accuracy, sensitivity and specificity are plotted in the bar chart format as well as in the table format. Thanks for watching this video.